Welcome to the EASE Workshop series. If you haven't already, please download the dataset we will work with today from the EASE website. The link is shown in the screen. Don't worry about opening it right now. I'll make sure you know when to do so. I want to make sure we are clear that this is assuming you have a basic understanding of Excel to the extent that we present in our Basic Excel EASE workshop, and it is by no means meant to be an all-inclusive class. At each step, there are many options that I won't have time to go over, so I encourage you to spend some time on your own playing with them. This workshop will introduce you to a few basic statistical analysis you can run using the data analysis add-in in Excel. The images are from the newest version of Excel 2016, which you can get through IT for free, and it's focusing on PCs. Older versions or those of Macs may look slightly different, but the overall concepts should still apply. If you are using a Mac today, make sure to have the most recent version of Excel. Older versions will not carry the data analysis add-in, which will add additional steps that we won't go over in this video. If you have older versions than the one used here, make sure you download the Mac guide from the EASE website so you have it to follow along. If you need a refresher or have not already participated in our Basic Excel workshop, you can take advantage of it through the EASE webpage. Topics that were covered include graphing as well as filter and sorting, which will really help when it comes to cleaning dirty data, including duplicate or misleading points or outdated information, to name a few. Some additional resources that are available to you through the EASE website are instructions on how to get Microsoft Office Pro for free for being a UNM student. There is also a file that guides you through the differences between PC and Mac versions. And for those of you that don't have the 2016 Excel version, we guide you through the use of Stat Plus rather than the data analysis add-in. Lastly, there is a document with links to videos on basic statistic concepts if you want to learn more about what is underlying each of the tests we will cover, as well as how to implement COUNTIF and if-then statements within Excel. This workshop will first cover a few basic concepts that are important to understand when doing statistical analysis. To make sure we are all on the same page, we will briefly go over some vocabulary terms in a how to do that in Excel framework. Then, I'll walk you through how to add and activate the Analysis ToolPak plugin. And finally, we'll go over how to run 3 different statistical analyses in Excel, but only briefly go into how to interpret the results. First, we will go over what functions or equations to use to calculate the mean, median, and mode in Excel using this example dataset. To get the mean in Excel, we type in equal average open parentheses. Cell first is the first cell in the dataset, and the cell last is the last. As you would expect, what that function is doing is adding each data value together, then dividing by the number of data points. Similarly, to calculate the median by hand is time-consuming, especially for large data sets, since you have to reorder the data in numerical order to find the central value. So the equal median and selecting your data is quick and easy. In the case of our example dataset, the median is 14. To calculate the mode, instead of having to search and count numbers in your dataset for the value that occurs the most, you only have to enter the mode function, equal mode, for your selected data. Now, the concept of variability isn't as straightforward, so let's spend a bit of time going over what this could mean. Within the larger idea of variability, the range is the breadth of the data. That is, the largest value minus the smallest value. There isn't a single equation for Excel to calculate this, so you have to do a combined function. The function in orange is what you would type in Excel. The maximum value within data in cell X through cell Y, minus the minimum value within the dataset. The variance of a dataset measures how far the data points are spread out from their mean. This is calculated as the squared difference of each value from the mean. So with this image, we are looking at the difference of each value represented by the red lines from the green line, which represents the mean. Then divided by the number of measurements, in this case 5, Wow, that's complicated and can get messy pretty quickly, so it would be much easier to let Excel do the work with the equation shown above in orange. Remember, we do have some videos available to you on the EASE website so that you can learn more about some basic statistics. Again, the equation you'd enter into Excel is shown in orange. This is for the variance of a sample set rather than a population. We don't have time to go into what that means, but make sure you are using an appropriate calculation of variance within Excel based on what's appropriate for your data set and test. The last form of variability we will cover, although there are many more types, is standard deviation. This measures how spread out the values are from each other and is the square root of the variance. As with variance, the standard deviation equation is for a sample set of values. Before you can run any type of statistical analysis on your data, you have to first know what type of data you have. There are two major types. Categorical variables are those that are qualitative or nominal. In other words, they do not consist of numbers directly, but of categories or names. For example, if we were comparing brands of shoes, the brand name is the categorical variable. Some of the other attributes associated with shoes could be considered numerical or quantitative variables. These are measured on a numerical scale. Discrete numerical variables consist of only certain fixed values with no intermediate values. Partial numbers are not possible. Shoe size, you can have a 4 or a 5, but not a 4.27. On the other hand, continuous numerical variables include all possible intermediate values. Variables such as foot size, since your feet can have any value within a given shoe size. Now that you know the type of data you have, you need to know what statistical approach is appropriate. The statistical tests that we'll go through focus on determining if two or more data sets are significantly different from each other or if the values are correlated. The null hypothesis is that there is no difference between data sets or that the data sets are not correlated. That is, they are independent of each other. An example of this would be to state that there is no significant difference between the means of two data sets that you are comparing. We'll see more of that later. The alternative hypothesis accounts for all other possible outcomes, meaning that there is a significant difference between the means of the two data sets you are comparing. To test the data in light of this hypothesis, we use a probability distribution table which links each outcome of a statistical experiment with its probability of occurrence. In itself, the probability doesn't mean anything, so we have to set a threshold that we are willing to accept as random chance, rather than a meaningful correlation. In other words, to be able to determine significance, we need to settle on a level of significance. How strong does the relationship have to be to reject the null hypothesis? This is seen as either an alpha or a confidence interval or level. Commonly used thresholds are alpha of 0.01, which is a confidence level of 1%, 0.05 or 5%, and 0.1, which refers to 10%. We have an alpha to determine how acceptable are our results. The smaller the value, the stronger the evidence must be to reject the null hypothesis. There are different levels because different disciplines have different requirements. For example, medical fields usually use a 1%, while ecology uses a 5%. Can you think of a reason behind this? Once you have settled on your alpha or confidence level, you can perform a test on your data and compare it to this level. To do this, we use a test statistic. The probability that the outcome is not statistically supported, assuming the null hypothesis is true, is known as the p-value. For example, a p-value of 0.041 means there is less than a 4.1% chance that the observed outcome is due to chance. If your p-value is less than the predetermined alpha, then there is a statistical difference between the groups in question at that level of confidence. In other words, you would reject the null hypothesis and accept the alternative hypothesis. Again, the significance of the p-value is based on the chosen alpha. Yes, the p-value has to be small, but it is all relative to the chosen alpha. There are 4 tests to determine if 2 data sets are significantly different or if they are correlated. The chi-square test compares 2 categorical variables, and that is as much as we're going to discuss about the chi-square today, because there is not a quick way to use Excel to run this test. In the case of regression, you compare 2 non-categorical variables within the same data set to determine if they are correlated or independent of each other. And ANOVA, which is analysis of variance, and t-test compare means and distribution across 2 or more data sets, comparing 1 categorical variable to 1 numerical variable. Earlier, we went over how to determine the type of data you have, but not how that relates to which analysis you should run. This graphic should help you with that choice. Match the hypothesis with the appropriate test, thinking back to what we have gone over. Feel free to pause this video to work this out. Let's go over which test would be most appropriate for each of these hypotheses. The first hypothesis would need a t-test, since you are comparing categorical and numerical variables. In the case of categorical, you have gender, and for the numerical, you have height. It is a t-test rather than an ANOVA, since there are only 2 groups being tested. When you run the t-test, you will get a resulting p-value. Remember, the alpha level you've decided on will determine if the p-value indicates the acceptance or rejection of the null hypothesis. In this case, the p-value is so small that the null is rejected at any of the standard alpha levels. That means there is a difference between mean and distribution of male and female height. This graphic is referred to as a box plot, and the whiskers or error bars on the boxes can represent upper and lower quartiles, 1/4 and 3/4 medians, standard deviation, or range. Which of these the whiskers represents needs to be specified in the figure legend and the text of the report in which this test is being presented. For the second hypothesis, again, we have categories of state and numbers in height, but we have 3 groups. Thus, an ANOVA rather than a t-test is appropriate. As before, when you run an ANOVA, you'll get a resulting p-value. If the p-value is significant, it indicates that you reject the null hypothesis that all means and distributions are the same, and that there is a difference among the means and distribution of heights. But from this, you cannot determine which pairs are different, just that some are different. You'd have to run additional statistical tests to determine which pairs are different. From looking at the graphic, it looks like New Mexico and Nevada may be the same, as are New Mexico and Texas. But Nevada and Texas are different. But again, to statistically determine this, you have to run additional tests. From this graphic, I would most likely follow up with Nevada and Texas and then go on from there. For the final hypothesis, since both temperature and latitude are numerical, a regression is the best type of analysis. As with other tests, you will get a p-value, which indicates if the relationship of the 2 variables is different than 0, different than a straight vertical or horizontal line. But there are other things to look at as well. The R-square value indicates how well the line explains the data. A 0 indicates a poor explanation, and a 1 is a perfect explanation. So, if you tie these 2 concepts together, you can have a straight horizontal line that has a slope of 0, thus a high R-square value, but a low p-value. In other words, the line explains 100% of the data, but there is not a significant correlation between the 2 variables. Or opposite to this, you have very scattered points, but the trend line is at a 45-degree angle, resulting in a low R-square but a high p-value. There is a correlation between the variables, but it is not easily predictable because the points are very scattered. You can also get the regression equation, which is the equation of the trend line. So, another example, all of these have significant p-values, but the R-squared are different. The first graph has a high R-squared since the points are fairly well clustered along the line, while the middle graph is a bit more scattered but still linear in appearance. The last graph is very scattered. Okay, now we get to work with some data. Yay! You can run all this test within Excel without the add-in by using the pull-down menu of functions under the Formulas tab. But the ToolPak makes it easier to find and run. To more easily do any of these analyses in Excel, you have to activate the Analysis ToolPak. This provides data analysis tools for financial, statistical, and engineering data analysis. Let's make sure the add-in is activated. Go ahead and open Excel, click File. At this point, Macs are slightly different. We will go through the process for both, starting with PCs. For PC, select Options. This will open an Excel options pop-out. Select Add-ins. You can see a list of activated add-ins as well as the inactive ones. If the Analysis ToolPak is not active, make sure the Excel add-ins is selected under the Manage field and click Go. You will then see a list of add-ins that you can activate. Check the box next to the Analysis ToolPak and hit OK. For Macs, as long as you have the current version of Excel, you will still use the Data Analysis ToolPak. If you are using an older version, as I stated earlier, you have to use the Stat Plus, which we guide you through with our supplementary material on the EASE website under the Advanced Excel for Macs guide. First, you go to Tools, and then you scroll down and select Add-ins. Then you click on Data Analysis ToolPak and click OK. And so whether you have a PC or a Mac, you should already be able to find Analysis ToolPak add-in incorporated under the Data tab, as you can see in the screen. Moving forward, the platforms are almost identical when running the stats. You should be able to follow along regardless of the PC screenshots in this workshop. Now go ahead and open the dataset you downloaded at the beginning of the workshop. Make sure to enable the file so that you can manipulate it. And if you didn't download it, go to the link shown at this time to do so. You will notice that you have multiple worksheets in this file. Each worksheet corresponds to a stats test we will run today. The first type of analysis we're going to cover is a linear regression or correlation. This looks at how strong two variables are correlated or associated with each other. If the variables are correlated, they form a linear relationship. The null hypothesis is that there is no relationship between the two variables, that they are independent of each other. The alternative hypothesis then is that there is a relationship between the two variables. This Excel output is an example of a regression analysis on the frequency of cricket chirps in relation to the ambient temperature. To determine if there is a significant relationship between the two variables tested, you look at the significance F value, which is assessed the same way you would a p-value. In this case, based on any of the standard alpha levels, the results are significant, so you reject the null, have no difference, and accept the alternative hypothesis that there is a correlation between cricket chirp and ambient temperature. On a side note, remember that just because two variables are correlated, it does not mean that one is causing the other. For the regression equation, you look at the coefficient of the intercept and the x variable, with the intercept being the final value and the x variable being the coefficient to x in your standard y equal mx plus b equation of a line. The graph is not made automatically, but I wanted you to have a visual of the data in relation to the output statistics. If you're not familiar with these graphs or how to create them, we actually go through this process in basic Excel, so you can take a look at that if you're interested. There are two R-squared values, R-squared and adjusted R-squared. The adjusted R-squared is always lower than R-squared because it is a modified version of R-squared that has been adjusted for the number of predictors in the model. So if you are doing a regression with multiple predictors, you'll want to use the adjusted R-squared value in your report. You'll have to learn more about this on your own, but for the purposes of this example, the R-squared is 0.697. Remember, the closer to 1, the better the line explains the data. Now it's your turn. Make sure that you are in the regression worksheet. This data are for the relationship between the selling price of a house and the size of a house. Before you can run your regression, you'll need to determine which variable is the independent, which would go on the x-axis, and which is the dependent, which would go on the y-axis. We cover this more extensively in our basic Excel workshop, but just to refresh your memory, the independent variable could cause a change in the dependent variable, but not the other way around. So for the variables in this example, for a given house, which value would be the dependent variable between size and price? Could the size of the house affect the selling price? What about the selling price affecting the size? We'll come back to this when we get to that point in the regression analysis. To run the regression analysis, select the Data tab, then click on Data Analysis. One thing I want to point out is the Help option, which is great if you want a description of each test to determine if it's appropriate. To run a regression analysis, scroll down and select Regression, then click OK. When the regression window appears, you'll select the desired data for the input Y and X ranges. Since you already determined which variables is which, this should be easy to identify. For the Y range, we will select selling price. Make sure to include the header row of Y, actual selling price. If you have trouble selecting the data, go back through the basic Excel workshop for practice. And for the X range, select the house size, including the header row. Make sure labels is selected if you want to include the headers, which is convenient for output labeling. It is also important to include this since when you highlighted the data, the headers were included. Check the box next to the confidence level to be able to manipulate the value. Make sure it is set to the value you want. In this case, we will leave it at the standard 95%. This is equivalent to an alpha of 0.05. Then, select the new worksheet option for the output and make sure to include a description like regression results. After doing all of that, you can then click OK. Now, you can pause the video and take some time to answer the following questions. What is the R-squared? Is the regression significant? And what does this tell you about the relationship between house selling price and size? If at this time your answer is not matching to what you expected, I encourage you to double check your selection and that the parameters of the regression are appropriately set up. The next test will be a t-test. Again, this compares the means and distribution of two data sets. As with many of the topics we're covering, there are various types of t-tests, but we're going to focus on the two-tailed t-test. Remember, the null hypothesis is that there is no difference between the means and distributions, while the alternative hypothesis is that there is a difference between the means or distributions. When you do a t-test in Excel, this is what the output will look like. You can see the mean and variance as well as the number of data points. The default hypothesis is that the mean difference is 0, but you do have the ability to change this if your research question warrants it. You can see the degrees of freedom listed as well as various test statistics. We're focused on the two-tailed p-value, which is in this case a 0.000474, assuming our chosen alpha is 0.05. The null hypothesis is rejected, meaning there is a significant difference between the mean and distribution of life satisfaction ratings in older versus younger adults. Now make sure you are on the t-test worksheet. This is data for two different groups, the categorical variable and their exam scores, which is the numerical variable. We've arranged the data differently than the regression data so that you can practice with different setups. Just like with the regression, select the Data tab, then click on Data Analysis. Scroll down to the t-test. You'll notice that there are 3 types of t-tests, but for the simplicity of this workshop, select the 2 sample assuming unequal variance. Do not select assuming equal variance unless you have tested for this. The unequal variance option is the conservative approach, which is better for us since we have not tested the variance across data sets. The variable ranges are referring to the numerical, not categorical data for each data set because variable 1 and 2 account for the categorical designations. You will designate the data ranges similar to how you did it for the regression analysis. If you leave the hypothesized difference blank, it will assume the null hypothesis is that there is no difference between them, which is the most common. In this case, we don't have labels in our selection, so we will bypass that option. Make sure your alpha level is at the level you want it to be, which in this case is 0.05. Lastly, as before, enter a name for the output worksheet, something like t-test results, and hit OK. As with the regression analysis, a new worksheet is created with the results. So go ahead and pause the presentation and take some time to answer the following questions. What is the resulting p-value of the t-test? And based on this, are the means of the two groups significantly different from each other? Lastly, we'll go over ANOVA, which is essentially an extension of the t-test. It is used for comparing the means and distribution of more than two groups. The null hypothesis assumes all the means and distributions are equal among all of the groups, while the alternative hypothesis is that at least one of the means or distributions is different. Unlike a t-test, an ANOVA does not tell us which data set or sets are different. You have to conduct additional tests to determine this. As before, this is what the output will look like in your ANOVA. This is from a comparison of water retention in 5 different brands of concrete. You can see the number of data points for each group, as well as the mean and the variance for each group. The p-value between groups is 0.0088. So the null hypothesis is rejected under all standard alpha levels, which means there is a significant difference between at least one pair of means or distributions. But remember, it doesn't tell you which comparison or comparisons is significant. It's your turn now. Make sure you are in the ANOVA worksheet. These data are for the effects of feed type on animal weight gain. Just like before, go to the data analysis ToolPak, but this time select the ANOVA single factor option. Since an ANOVA is multiple comparison in one, you can't select an X and Y value or a group 1 and 2. So you'll select the entire range of all data values. You can include the headers and should so that the output has the groups by name rather than just by 1, 2, 3. Since you highlighted the headers, don't forget to click labels in first row and designate that your data is arranged in columns rather than in rows. Make sure that the correct alpha level is indicated and make a name for the output worksheet. Then click OK. Now pause the video and answer the following questions. What is the resulting p-value of the ANOVA? Are any of the groups significantly different? And are all of the groups significantly different? I hope you found this workshop helpful. Don't forget about all the resources available to you through the EASE website. Lastly, please take some time to complete the exit survey available under the Survey tab in your Excel file. We value your input and make adjustment to the presentation in accordance to students' constructive suggestions and needs. Thank you for listening.